Well, hello, Packaging 450. This is lecture 18, so we are at the end of the course. So today I am going to wrap up, going to talk a little bit about lean and a little bit about the entire, I'm going to go through the whole process of how to handle automotive packaging. And I'm going to go into defining a little bit between the difference between expendable packaging and returnable packaging, so you can distinguish between the two, some of the criteria. And then I'm going to round this out with the standard calculation for how to calculate returnables. Again, just to reiterate that. Again, your homework is already out there. It is the last half of what we had from homework 5. There were 10 questions, and I split them out between homework 5 and homework 6. And then there's also extra credit. That assignment is in the system. I'm also having office hours on Friday, August the 12th from 4 to 5. So if you have any questions, you can always email me. I'm catching up on emails right now. But you guys have done a great job, a lot of information to process. You guys have been through that, and I'm really impressed because you all are working full-time internships, basically being full-time employees, and you're juggling the responsibilities of courses. I'm actually really proud of you, to be honest, because this is a lot to deal with and a lot to do. I know a lot of the people are moving right now. They're in the process of rounding out their internships, finishing them up, doing final presentations, getting all the paperwork in that they need to close out, and closing up shop at their internship, and then getting ready to start the new semester when they get back. So you guys have a lot going on. Welcome to life. Welcome to adulting. And I'm proud of you all. Okay, let's get started. Again, I'm going to share my screen. And let's see. Okay, share my screen. And let me go back and make sure I'm actually at the beginning of this presentation, because it doesn't make sense if you see it from the middle. Okay, so again, I've got a summary here. I have a good number of slides we're going to go through. I might even take a little pause break at some point, but I'll continue from that slide. So hopefully it will be pretty seamless. Okay, so, and this might go a little bit over 2 hours, just so you know, because I know some of the other ones were slightly under 2 hours, but this one, I want to just make sure I have everything in here that you need. So let's get started. Okay, first, again, this is a summary of automotive returnable packaging. So again, I'm going to touch on expendables, but really the crux of one of the things that distinguishes automotive packaging from other packaging is the fact that they have been instituting returnables for so long that it is an accepted practice and it's an assumption. So just so you know. Okay, so next, here is I just have this graphic here. It mostly represents some of the things that are going into the whole process for packaging that once those inputs are go into the system, the packaging engineering or design team can start looking at what are their options for packaging. So, first of all, you got things like quality, safety. AME would be advanced manufacturing. There are various names for that group at different automotive companies, but it's basically the engineering team that figures out what does the line look like. They're the ones that will figure out, are they going to have skillets? Where are lift assists going to be on the floor? They're going to do that whole layout, and they also need to make room for the line side packaging. So their input's important. And then just making sure that the standards that exist are followed. And if the standards that exist don't work for developing packaging for the company that you're at, then it's up to packaging engineering, which would be you, to make sure that the standards are updated to reflect a process that is really robust and that works for the packaging that you're developing or bringing in. Then another thing you need to be aware of would be things like commercial agreements, what kind of customers you have, and then what kind of suppliers you have. The customer or the commercial agreements that I mentioned, and a really good example of that would come in when I talked about, the lecture about rental companies and lease companies, and understanding what that looks like, because the packaging that is brought in, it's not just making sure the product fits on the pack and that it ships safely, or even that line side it's okay. You want to make sure that you can return it easily. There's a good way to keep track of it. You have processes in place to make sure that there are not any extra fees or exorbitant fees that are charged, because there is no discipline in how containers are handled or managed once they're emptied. When they are going, where are they going back to? Are they going back to the same supplier over and over again? Are they very specific? Are there defined routes, or are you looking at a generic package that could go to pretty much anyone? So those are some of the things you need to keep in mind with commercial agreements. I can even think of some current examples of one of the customers I have with consulting, where they made a commercial agreement with their customer, and it's costing them a lot of money because the agreement had to do with the border crossing, and they put in a high cost on the box. The cost of the packaging seemed to be pretty high, so it basically, based on all the numbers, it turned out that maybe we'll either have to do repacking for the product, which you really want to reduce the number of handles, and you'll see that later, or you maybe get red flagged at the border because of the packaging and returnables or expendables or whatever it is. So there are just a lot of factors that come into play. And then you're looking at things like the component design, which would be what are the characteristics of the part. Is it E-coated, which means it has a special coating on it that needs to be protected? Is it scratch prone? Is it prone to electrostatic discharge? Does moisture affect it in any other way? Is it fragile? Is it going to break or crack, or will it stop working if it's dropped or hit and you kind of impact? Anything that really deals with the component design. And then, where are these being manufactured? Is it one location and you have a lot of uniformity? Sometimes you have one plant and you have multiple locations where this part might be installed and they're all different and you have to accommodate for that. Or maybe you have multiple locations and all those locations are very uniform. It's kind of like going into a McDonald's or Burger King around the world. No matter where you go, everything's set up the same. Or you may have multiple locations and they're all totally different. You can have, the English units like inches, or you could have metric units in different parts of the world. And you've got to match those up, and they've got to be very similar or the same. How do you handle those things? And then, the transit routes are totally different, what you're protecting from. If you have a location where there is transit by truck and the roads are rough, you are going to have to protect your packaging, or your product is packaging going to have to protect your product one way, versus if it's on an ocean container, you're protecting from moisture and heavy sway, things like that. Or if you're on a truck or rail car or an airplane, those are some of the things that you want to take into consideration based on the location of where they're being manufactured and where and how they're being shipped. And then you just have information on the program with the volume. You could have a low volume product, low volume vehicle, and the packaging approach would be totally different than if you have a really high volume vehicle. So those are just some of the many factors that come into play. So again, these factors, I'm so sorry, my eye's itching. These factors get funneled in to the packaging engineering team as inputs. they figure out from those inputs what's going on, how do they fit into their standards, how do they fit into the company standards, how do they fit into standards for transportation, standards for protecting specific parts. You want to, again, I'm going to keep saying standards, standards, standards. That is the key to reducing and eliminating as much chaos as possible in the system, because automotive can be very chaotic. So the more you can calm that chaos down on the packaging side, the more efficient you can be, and the more you'll be appreciated. And then just understanding too, if you're using returnables, what packaging is available? Can you reuse packaging? Can you upcycle it, recycle it, repurpose it, repair it? What things can you do? What's available? That always reduces cost as well, if you have a pack that you can use for 10 years. So those things save a lot of money. And then you have things that are influencers when you look at the life of the program. We did the calculations before, and you can see the cost for logistics or trucking, it can have a huge impact. So if you have a pack that is returnable, but it's not collapsible, the impact of the cost is so much higher than it would be if you have something that has a collapsible, returnable, and it has a high ratio, like a 7-to-1 ratio versus a 2-to-1 ratio. Those things can have huge impacts over the life of a program. So again, I know many of the times we just assume 5 years. In many of the case studies that we talked about, sometimes they go 10 years. But either way, when you just look at that impact of what the cost is with all the different scenarios, that's really important. Also, you're looking at how the packaging affects the piece price. So you can see that over the life of a returnable, you have what seems to be a pretty big chunk of outlay initially, but when you spread that out over the life of the program, by each part that's made, it diminishes that cost quite a bit, versus having an ongoing cost or an ongoing fee for something like a leased container. You're looking at, also things that would influence it would be, do you have to repair the package a lot? Is there any reason why repairs are needed? Is it a handling process? Is it a housekeeping issue? Is it something related to the discipline of the following the processes to keep the packaging safe? There are just a lot of reasons why your repair or replacement budget could get high. Things like theft. If you are shipping the products along a route that for whatever reason may be prone to theft, or if you have someone or a system within your facility that has figured out how to siphon containers away, then that would be another example of having loss or theft. Just a lot of reasons, or just misroute. So you have one plant or facility or a supplier or customer that would just use the word greedy, and they take all the containers, whether they're using them or not. And you'll actually see an example of that I've mentioned in the next slide. Other things are like the line side presentation, things that have to do with the warehouse layout. How do those things impact the labor force? Do you need more people to handle a certain pack? Can you reduce the number of people based on the type of packaging that you have? It can also affect the material flow. So, there are so many things that get involved. I didn't even talk about like border crossings and customs. Again, it seems like you can go on and on and on for some of these things, but they can be very impactful. Something that seems like not a big deal, when you take it over periods of weeks, months, years, over high volume spread out over time, it adds up to be pretty significant. So it's always good to do your calculations, do your comparisons, look at all the factors. And that's why doing something like a value stream map is important. This is a book I have from way back when. It's called Value Stream Management. It is by Don Tapping, Tom Leister, and Tom Shuker. But there are a lot of books out like that that talk about value stream mapping. It talks about how you can lay out a process map. I'm trying to find a good picture in here where you can actually see what this looks like. Okay, here's on the back page. Okay. I don't know if you can see this, but this is basically a diagram that is laying out what the process looks like. And if you Google value stream mapping, and you'll see at the bottom, they have these little boxes, and those boxes actually are listing things like, what is your takt time? What's your process speed? How many parts are you doing? A lot of different information. It tells even what the interval of time is between the different processes. And it goes from like bringing parts in, shipping parts out, going to a new facility, if there's another process, or even going to the customer. There's also room in this value stream map for technology. So while you're mapping out the physical process, you're also mapping out data points. So at a certain process, what pieces of data are collected, and then where is this data collected? So an example would be, the information comes out for volumes. So, how many parts are made each day? That would feed into, say, your production control or material management team and purchasing, because they need to know like how many parts are being pulled in, or being bought. Manufacturing needs to know that information so they can plan ahead. Packaging would get that information because then they know like how many containers you're going to buy over time. A lot of different things feed into that. But as you draw that map of how the product is being made, you could put in there how many packages are being used. But then you also would put in, like I said, those data points, where those data points fall in, when is this data being collected, and then where is it going to? So there would be, you might have a box for process number 1, but then above it, you show, basically, you would diagram the computer or the building that all the data is housed in. And then there might be a line that comes down from where that data is housed, and it's showing it. So it's representing that data is coming in at the same time this process happens. And it might even show data that comes out. So you bring in so many packs, so many fasteners, so many parts, and then outgoing, there'd be data to say, this is a finished product. So we took in 4 fasteners and all these other parts for this particular component, and you put those 4 fasteners together, it will equal that one assembly. And then you show a diagram. On that diagram to show a line for data to show now you have 1 assembly or 1 part, or however many parts you have. So the value stream map shows pretty much it's a really good diagram. So Google that. And you will actually see a lot of information that I'm showing on this screen here is captured in some shape, manner, or form in a value stream map. Okay, so next, this is something that I put together. This was an example of, the future, like technology that is being utilized based on the packaging. The packaging can drive technology. So, for example, you've heard me talk many times about this particular location where they were screaming every month or every week, whenever they could, we are out of packaging. And they were getting sent these containers all the time. We were spending $10,000 every single month just to make sure that this one plant had enough containers. So we were spending $10,000 on new containers, plus any other location that used that container, whether it was inbound or outbound, they were shipping their extra containers to this plant. Meanwhile, then the other locations start running out because where is it going? We're looking in the system and technology. All the packaging shows up at this plant that's begging for containers. It says they're always out, but they weren't going out, and then everyone's starting to run out. So this is telling me they're pooling somewhere. As you know, we talk about how there's not much room in the manufacturing plants to hold large amounts of packaging. So that made me look on Google Maps. When I went to Google Maps, this is what I saw. This represents 53-foot trailers. You can see those white rectangles are 53-foot 18-wheeler trucks, the trailers without the cab to pull them. These were parked and dropped out in the yard. So you can see how big these are. This is the packaging that we were sending. That black oval shape, that was the packaging we were sending every month to this location. It said they were out. They were out. When I saw this, I said, well, why do you have all this in the backyard? Why is this outside? And they were like, well, we get them in and then we use what we need. And then we don't want to go back because we have scorpions and snakes and spiders and whatever else. They didn't want to go back and clean it up. So they're accumulating and basically hoarding all the packaging and not using it, causing a lot of cost to the location. Another thing that you can do, you have trailers. You can see sometimes people say, oh, we never got the trailer in. And we can look on GPS and say, oh, actually, the trailer is sitting at door number 7. So they can actually locate things. So packaging can be a very powerful tool because it can be used to track the packaging, track the containers, keep track of things. Another use for using packaging to track would be radio. So if you're sequencing radios, you can have a container that maybe has some sort of tag on it that can be scanned. And you know that within that container, you have 10 radios, and they are packed in order of the sequence of the vehicles that are coming down the line. So there are just a lot of ways to do that. One thing that is important is that doesn't matter how much technology you can have great technology, but if you don't have the discipline to run a process, you're only going to get garbage data. So you'll probably hear, if you haven't already heard, the term garbage in, garbage out, or GIGO, GIGO. That means that if you have a process that's not good, trash, crappy, garbage, whatever you want to call it, it doesn't matter. So it's kind of like, let's say you have say we have a Ferrari, right? You have a Ferrari, but the person has never taken a driving lesson. They're not, no matter what the capabilities of that vehicle are, that person without any experience of driving is not going to be able to utilize or maximize all of the capabilities of that Ferrari. And they're gonna drive it like they're driving a school bus or something. So same thing with manufacturing. You can have the greatest processes in the world, but if you don't have a system in place to manage containers, to manage the process, if you're not training people on how to build the vehicles or build or handle the packaging, whatever that process is, if there's no training or skill put to it, or discipline, you'll still lose containers, or you still won't have the right containers. So those are just some of the things that I wanted to mention. There's technology available, but you've got to have the discipline process laid out. Practice before you implement it to make sure that even if the power goes out, even if the computers go down, they can still run that process. They may not be able to collect the data, but their process remains the same. And even if you have a really good process, if you have a backup process for, let's say, a power outage, which might be all paper, it should be pretty easy to input that information in or capture the information when the system's back up and running. So that's part of having a robust discipline process, is even if the technology's down, you should still be able to run efficiently and smoothly and capture the data of what was run. Okay. All right, so talked about this earlier. Just wanted to kind of go over again the processes that you look at when you are launching packaging for a new vehicle or a change to a vehicle when they're launching. The process itself is basically because think about this, if you're a packaging engineer at an OEM or even at a larger tier, and you're getting packaging in from your suppliers, you want your suppliers to design the packaging, because first of all, they know what their part performance is, they know what the requirements are, and you want to be the reviewer. You want to make sure that they've met your standards, they're following the rules, it's not causing any issues on the manufacturing side when that part arrives to you. So the supplier needs to design the pack. Sometimes people don't understand that, and they'll tell you, I have one now, they're like, we want you to draw a gallon pail. I'm like, what's going in the pail? Am I getting a plastic pail and it's a chemical that's corrosive and it's going to melt the petroleum base, it's going to melt the pail? Or did I get a metal pail? What type of lid? What exactly does it need? So those are some of the things that it's important to know, and why the supplier should design it. Also, they need to have sample packs that they need to create, and you need to be able to have a fit check. And I would say you, as a packaging engineer, you want to have a physical sample of the pack. It could be a prototype pack, it could be a dummy pack. And you also want, for the fit check, you want a part. It doesn't have to be a working part. It doesn't have to be a complete part. You want something that fits. So it could be a 3D printed part. You want it to make sure that this part fits into the packaging. Okay, that's the first step. You want to make sure you get multiple prototypes. So you want to make sure it fits, and then you're also going to later, get prototypes that work, because when you do your packaging testing, that comes later. So, but this is when I talk about this sample pack created with parts. That is a fit check. You want to make sure that your parts fit, that they're not doing anything unusual, that it's going to basically show you, okay, they do, the size is correct, the shape is correct, and this is something that is worth going forward with on testing. Not approved yet, but this is worth going forward with. It meets the minimum criteria. And then when they do that, you also want to have some sort of packaging data form. Some people call them, packaging information, whatever it is. You want to have a packaging approval. You want some sort of format that's standard for your company, that suppliers will submit their proposals to you to say, this is the packaging that I plan to use. It should have photographs, it should have details on the size, it should have weight information. It should, also have some like logistics information on where these parts are coming from. Just things that will help you decide whether or not this packaging is acceptable. You want to make sure that from a packaging standpoint, you look at it to make sure it fits, but then you also want to make sure from some sort of production process that somebody on the production side looks at it, because you want to make sure that this doesn't cause any red flags early on from line side operator standpoint. And you also want to make sure it doesn't cause any issues from a material standpoint. So I think I gave an example earlier where there were, 3 or 4 different parts coming in and they wanted to use the same size tray. One tray, one part they were going to put like 19 parts in, another one they were going to put like 27 parts in, another one they were going to put like 6 parts in. I'm just making up numbers. But as you can see, those numbers, they aren't even multiples of each other. So you're not ordering even sets. So you're not ordering like 6 of one and 10 of the other to get 60. Another reason why I mentioned like the number 60 is because you want to understand what their cycle time is or their takt time. How long does it take to build one part, one truck, whatever it is? What is that cycle time? Many times it is going to be metered around 60 per hour, 1 a minute. So having things that are multiples of 60 or 30, that is consistent with that takt time, right? So those are just some of the things to look at. I mentioned that packaging data form. You have people that look at it to make sure there's no issue. And then you might need to do another sample pack review because you might need to do revisions because, like I said, maybe the packaging is set up where it doesn't match the takt time, or maybe the part is placed in the pack in a way that's awkward for the operator. So they have to pick it up and turn it. And maybe that makes it prone to being dropped. It's a part that may be sensitive to shock or impacts, or just may put people at risk for some kind of repetitive injury. So those are some of the things you want to look at. So you want to make sure that if there are any issues, you want to make those changes early before they've committed to tooling, before purchasing is made, agreements and contracts and signed off on. This is the part, this is the pack, this is the price it's going to be. Because if they say the pack is going to be 10 cents, but then you find out that it's not protective enough and you have to make some changes to make sure that the part is protected by the pack. Maybe now the pack price goes up from 10 cents to 20 cents. So now they're spending twice as much per part on packaging than they planned. So now they've said, okay, this part is going to be $1 and 10 cents of that is packaging. Now all of a sudden it's going to be $1.10 because you've added 10 cents to the price of the packaging. Just some examples. The next step would be you want to make sure that packaging proposal information is usable and is accurate. If you want to help the sourcing or purchasing team, procurement team to be able to understand what the price of the pack is, what's the cost of the pack, so that they can accurately determine how much of the cost of that packaging is going to be the cost of the part. And then next you're looking at, having reviews with the plant, with the packaging data information or the packaging proposal. So notice that this proposal form is a tool that needs to be used throughout. Anytime there's a change, they update it. But this is a lot of information. A lot of those inputs I talked about would be on there. And it just kind of lets people know from, each different department that is impacted by packaging, from whether it's supply chain or manufacturing or advanced manufacturing, product engineering, any of these different departments. You just want to make sure that they can see, they can see the information impacts them. They also can see, all the pieces of information, and they're like, I don't need that. But okay, you don't need that. This isn't your section. This is purchasing section. And sometimes they'll go, oh, okay, I get it. And they kind of see how it fits for them. So they may not get it at first, but they'll appreciate it later. Next, again, you've got revisions. You want to make them as early as possible. You want to do it before there's a commitment to pricing or tooling. And then after all the approvals are done, which would include like a PPAP, which would be a pre-production approval process that's done by quality. Once that's done, then the purchasing team can kick off buying the containers, or whatever that agreement is. If it's a returnable and if it's an OEM, and the OEM would have their supplier make that physical purchase, but then they would take ownership of the packaging and pay that supplier back over time. Whatever that agreement is, you want to make sure that from a packaging standpoint, it's signed off and approved, because there's nothing more fun than to get packaging in that's not approved, that the supplier is just like, here you go, and you got to live with it. You find out that it's already been signed off. Any change will cost a lot more money, but it's damaging the product and kind of stuck. So you really don't want to deal with that. Okay. Next, I cannot, again, stress this enough. The packaging process is a team effort. So you probably wonder why you have these team projects in packaging, right? Because when you get out to the work world, you are not working in a vacuum. You're part of a team. Packaging touches the entire value stream, a value chain of a manufacturing process, all the way from things like the resin, how that resin comes in, if it's a raw material of any sort, all the way through manufacturing, all the way to shipment, all the way to your customer. So packaging gets involved all the way through. So that's why it's important to see yourself as part of a team. You're providing services of design, services of approval, services of giving guidance on, how the packaging can affect a part. Maybe you have a part that the design has a weak spot. So you're not going to redesign the part, but maybe you can give information that would drive the product designers or product engineers to modify the design. So I think I'm going to take a little break here, but I just want to mention after this slide that, these are key team members. You've got, obviously yourself, the packaging engineering team, your suppliers and their entire team, the purchasing, procurement, sourcing group, whatever they're called, your program manager who is running that launch, and they're coordinating all this. So they're working with all these people as well. But then you're kind of working behind the scenes with these people as at the same time. So they're focusing on the product. They're touching base with you to say, how's the packaging going? But you're kind of like a sub program manager for packaging for the whole launch. So just kind of keep that in mind. Materials management. So people in the plant that are, keeping track of how much material needs to come in, how much material do we have, when does it need to come in, where does it need to come from? The launch manager, because sometimes some plants will have a launch manager assigned. So it would be someone that would be working at the plant level with the team in production as it gets closer to starting and kicking off a new vehicle, and they're making sure everything works. And they're making sure the equipment for the new vehicle on the line works. To say the skillets, maybe they've made some modifications to the skillets to handle this new vehicle. The launch manager would make sure that when they do they do pre-production testing, that the skillets work. But they also would make sure that the packaging works, all these sorts of things. Then you've got like the logistics teams. You've got the people that are scheduling trucks, the people that are making sure the trucks are parked in the right place, that there's room for them, that they know where to park. They have processes on where they're coming in. The supply chain manager, which will be dealing with more on like the coordination of, ordering trucks, working on like what materials are coming in, how often they're coming in, They're working in coordination with the launch team, materials management, and purchasing. The supply chain manager, same thing. Supply chain many times in automotive, it includes the logistics, the trucking, transportation team, but sometimes it also includes the packaging team as well. So, just keep that in mind. So, then you got advanced manufacturing. You've got industrial engineers at the plant or any other plant engineers that are working on a day-to-day basis to make sure that the ergonomics or the timing of manufacturing, because they want to maybe have like 3 different operations at one station on the line, and to get it within that maybe 60-second tack time. But maybe they have 5 different operations there. Now, the person's taking a minute and a half, but the person, if at the next operation, is kind of sitting there waiting because they only have maybe 45 seconds worth of processes to do. So maybe there's some work that this operator, it's a little overtaxed, can push over to the next process. But that also, in fact, impacts the packaging, because that will say this, now the packaging is going to be staged in a different area. Is there room for that? And then with this operator, maybe the operator is going to be doing it, more manually versus with the lift or something. They have a lift at their station, so they're using big, bulky bins. But at this station, maybe most of the operations are hand operations. So they got to, finagle that. The packaging might change. You got engineering management. You can get involved with leadership and you're doing, presentations. And then, of course, you've got your customer. The customer is really what this is all about, right? So there are a lot of people on the team, and they're all important. They all have roles, they all have information, they all have inputs, and they all have outputs that they get from you. So just keep that in mind. I think I'm going to break here. So when I come back to the next slide, hopefully it'll be kind of seamless, but I just want you to know that in case you see a break. All right, we'll take a break now.